So we want to look at graphing equations, and we see that a solution point is an xy pair or a point that satisfies an equation. So if we are asked this question, is the point negative 3, 5 a solution of the equation 2x plus y equals negative 1, what we're asking is, if we plug in negative 3 and 5 at the same time into that equation, do we get a true statement? So if we change x to negative 3, we change y to 5, and we simplify this left-hand side, 2 times negative 3 is negative 6 plus 5, and then negative 6 plus 5 is negative 1, so negative 1 equals negative 1, then yes, that is a solution point. Let's say we were asked, is the point 7, negative 13 a solution of 2x plus y equals negative 1? So again, we're trying to determine if when x is 7 and y is negative 13, we get a true statement. So we substitute those in. 2 change x to 7 plus change y to negative 13. 2 times 7 is 14. 14 plus negative 13 is positive 1, which is not negative 1. So no, that is not a solution point of that equation. If we plot all of these solution points, what we'll see is that these typically form a pattern. For us, the pattern will be a line, but there's more complicated types of equations, more complicated graphs that form different patterns. So we'll stick with lines for the time being, but you can have more complicated types of equations. To find the solution points, typically what we do is we solve for y, and what that means is get y by itself on one side of the equation, get everything else on the other side, and then we substitute some values in for x. And we determine, calculating on the equation, what is the y value that has to go with them. So when x is this number, what's the y that's its pair? And that'll give us a list of solution points. This is the most fundamental way of graphing an equation. So anytime you run into an equation and you're not sure about how to graph it, you can always fall back to this technique of picking points called pointwise graphing. There are usually, for different types of equations, different techniques to use, and we'll explore the techniques for lines in this course. But there are other types of equations, they have other techniques used to graph them, but this is always the fallback way that you can always use to graph an equation. So let's say we wanted to graph 3x minus 2y equals 8. We could plug numbers in the form it is already, but it's easier if we solve for y first. So we want to get that 3x, that term without a y, to the other side of the equation. So I'm going to subtract 3x from both sides. Notice 8 and 3x are not like terms, so I'm not actually going to combine them. I have a positive 8, a negative 3x, so negative 3x plus 8. Now to get y by itself, I have to get that coefficient of negative 2. So I'm going to divide everybody by negative 2. Now why am I dividing everybody? You don't subtract 3x from everybody. Why do you divide everybody? So the reason why is what I'm really doing is I'm multiplying both sides of the equation by a negative half. And you'll notice on the right hand side, since I'm multiplying that side by a negative half, I need to distribute it to each part of that. So what we're doing is, what you're seeing on the right hand side with me dividing everybody by negative 2 is really the distribution property of multiplication. And then, multiply those together, so 2 divided by 2, 3 divided by 2, 8 divided by 2, and so I get y equals 3/2 x minus 4. So I've solved this for y. And now what I'm going to do is I'm going to create a chart of values. So I'm going to put that in there, I'm going to pick some x's, and because I saw that I'm going to take x times 3/2, which will give me, if I don't multiply it by an even number, it's going to give me some decimal or fraction value. So I'm going to choose even numbers, and I don't want to draw my graph too big, so I'm just picking negative 2, 0, 2, some 3 small even numbers. Now it only takes 2 points to draw a line, but if you do 3, then you'll know whether you made a mistake or not. If all 3 don't line up with each other, then something had to be wrong. You don't know who was wrong, but you know something was wrong. If you only do 2, you can always draw a line through 2 points and you won't know if you made an error. Alright, so I'm going to substitute -2 in for my x value, and then I'm going to calculate, and that'll give me the y value, because y equals this answer. So 3/2 times -2 is -3 minus 4, so y is -7, so I have a point at -2, -7. When x was -2, y is -7. And then I'm going to do that for 0 and 2, so I'm going to substitute 0 in for x. 3/2 times 0 is 0, minus 4, that means y is -4. So when x is 0, y is -4. Substitute 2 in for x. 3/2 times 2, the 2's cancel out, you get 3. 3 minus 4 is -1, so when x is 2, y is -1. And then I'm going to plot these 3 points. So here's just those 3 points again, and I'm going to plot those. So 0, -2, down there in quadrant 3. 0, -4 is on the y-axis, down 4 units, and 2, 1 is over in quadrant 4, to -1. And now I'm going to draw a line, and you might want to use a ruler or something to do this, make a nice straight line through those points. And the idea is you could use this line to predict other values, because there is an infinite number of pairs of numbers on this line. So for example, if I said, what's this pair of numbers? So I'd look at my graph, and it looks like this is 5 and 3.5. I'll say 3.5. So is that really a solution point? So I go to my equation and I substitute in 5 for x and 3.5 for y. Notice I went back to my original equation because that's really the one I was given. I might have made a mistake earlier, and so always go back to the original when you're checking things. Let's see, 15, 2 times 3.5 is 7, 15 minus 7 is 8. So that does check. That is a solution point. There is another way to graph, and again, this isn't necessarily just limited to lines. This is other types of equations as well can use this, though the more complicated the equation, the less useful this is directly. And that is to figure out where the intercepts are. What that is the points where the graph intersects the x and y axes. So let's look at some points on the x-axis. So if I look at this point, this has coordinates -2, 0. If I look at this point, -2, 0. Look at this point, 1, 0. And look at this point, 5, 0. I notice all those points on the x-axis have the same y value. They all have a y value of 0. So if I want to figure out where a line hits the x-axis, what I want to know is what's the x value when the y value is 0. So I'm going to change y to 0, and then I'm going to work out the problem and figure out what x is. And once I have that, remember, these are points, so they need to be written as an ordered pair, 2 numbers. The y value is 0, that's what we made, and then you'll get some number for x. If I look at the other axis, let's say I look at this point, 0, 6, 0, 4, 0, -3, 0, -5, I notice in all of those cases, on the y-axis, the x value is 0. So to find the y-intercept, where my graph would hit the y-axis at, I'm going to make the x equals 0. And then work out what y is. And since I made x equals 0, then the point is going to be 0, comma, whatever number you get for y. So let's say I want to graph this equation using the intercepts. This isn't the best way of seeing an equation written for the intercepts, but you may run into this type of problem, so I wanted to show it to you. So to find the x-intercept, I'm going to make y equals 0. And now I'm going to solve for x. So I need to get x by itself, so add that 3, and then get rid of the coefficient, divide both sides by 2, and I get x is 1.5. So when y was 0, that's what we made it, we got an x value of 1.5. That's my ordered pair. Those are 2 values that go together. Now if I want to find the y-intercept, this time I make the x equals 0. So I'm going to say 2 times 0, well 2 times 0 is 0, so y equals -3. Hey, I'm done. So the y-intercept, x was 0, y is -3. Notice those 2 numbers go together. Do not put 1.5 in the same parenthesis as -3. That is not a point on the graph. there's a point at 1.5 comma 0, and there's an entirely separate point at 0, negative 3. So I'm going to plot those. 1.5, 0 is on the x-axis, 0, negative 3 is on the y-axis, and now I draw my line. And remember, you only need 2 points to find the equation. Now, of course, the danger here is because I only got 2, I don't know if I made a mistake or not, but you know what we're trying to do is have a slightly faster way of doing the problem. Let's look at another problem, and I'm going to start using the intercepts just like I did on the last problem. This way is written is a little easier for the intercepts, but it's got its own issues, which we'll find out. So x-intercept, I want to make y 0. So 2x equals 0. Get rid of the 2, divide both sides by 2. 0 divided by 2 is just 0. So x is 0 when we made y 0. So 0, 0 is the x-intercept. To find the y-intercept, we're going to make x 0. So 2 times 0 minus y equals 0. So let's figure out what y is. 2 times 0 is just 0. So that's negative y equals 0. Divide both sides by negative 1. Get rid of the negative sign. And you get y equals 0. So when we make x 0, y is 0. And I hope you begin to see what the problem with this particular situation. I only have 1 point. I can't draw a line with only 1 point. I need 2 points. So I need a second point. So if your line happens to go through the origin, you're probably not going to be able to find 2 different intercepts for that. So I need to pick another, I need to find another value. So what I'm going to do is I'm just going to pick a number for x. Just like we were doing the pointwise graphing, I'm going to do a little pointwise graphing here. So 2 times 1, I'm going to pick x value of 1, and I'm going to figure out what y has to be in that case. So 2 times 1 is 2. I'm going to get y by itself. So hey, why don't I just add y to both sides, and then y will be on the right-hand side, and I'll get y equals 2. So when I made x1, I got a matching value for y of 2. And so I plot that. I got 2 points. I could draw my line. So intercepts are nice because they can be a kind of fast way to do it, and you only need to find 2 of them. But like in this case shows, you might run into a situation where there's not enough information because the line goes through the origin, and you might have to still find another point. Alright, a couple of special lines that you're probably going to run into. Horizontal lines. Horizontal lines always have the equation of y equals a number. Or it might be like y plus a number equals 0, and then you could move the number to the other side. But typically we see it as this, y equals a number. So like for example, y equals 3. So if I try to do my pointwise graphing here, see how that goes, I'm going to pick some numbers for x. I just picked negative 3, 0, 3. That doesn't have anything to do with the fact that y is 3. I just picked those 3 numbers just for the heck of it. So if x is negative 3, we're going to change all the x's in our equation to negative 3. Which means, well, we don't have any x's in our equation. So what does our equation say? Y is 3. So when x is negative 3, y is 3. So negative 3, 3. When x was negative 3, y was 3. What if x is 0? Well, again, y is 3. So y is always 3. So 0, 3. What if x is positive 3? Well, again, y is 3. So when x is 3, y is 3. Notice the y value is always 3. That's what the equation is telling you. Equations are about restriction, not about freedom. They're saying this has to be true. In this case, they're saying y has to be 3. Always. Doesn't matter what x is, y has to be 3. So if I plot those points, negative 3, 3, 0, 3, positive 3, 3, and I draw a line, notice I get a horizontal line. So when you have an equation like y equals 3, what you're looking at is a line moved 3 units up. So it's at a height of 3. In other words, we're looking at every single point whose y value is 3. Notice x can be anything we want it to be, but y has to be 3. The other special line, we're going to look at vertical lines, and they have an equation x equals a number. And that may seem a little, different. In the previous one, we had y equals a number, and before we got y by itself, y equals something with an x. Now we're going to look at, well, x equals a number. So for example, x equals negative 2. So for that, what I'm going to do is I'm going to pick some y values this time. I know normally we pick x values, but in this case I'm going to pick y values. So let's say y is negative 4. Then what is x? Well, the equation says x is negative 2. So my point is negative 2, negative 4. What if y is 0? Well, again, my equation says x equals negative 2. So I have a point at negative 2, 0. What if my y value is 4? Well, again, there's no y values to change to 4s. It's just x equals negative 2. So negative 2, negative 4 is a point. So if I plot those, negative 2, negative 4 down in quadrant 3, negative 2, 0, that's on the x-axis, negative 2, positive 4, that's on quadrant 2, I see I get this vertical line. It's every point 2 units to the left. So x equals negative 2, x equals negative 2, x equals negative 2. It's every point where the x value is negative 2. So those can kind of throw people off a little bit when you first run into them, because they may not behave exactly the, they look kind of strange, and they are strange. But it's saying x equals negative 2 is every point 2 units to the left.